Good morning, good morning, good morning. I'm so excited. We're starting Algebra 2, Common Core. This is day 1. The cool thing about this day is it's sort of all review. By the way, if you don't know who I am, my name is Mr. Krause. Ken Krause, Mr. Ken Krause. And my partner in crime is Miss Vicky Newman. Together we make NK Infinity. Now, why you say NK? What the heck does that say? Oh, it's really creative. Newman Krause. Newman Krause Infinity. And we just like infinity because it's kind of cool. It never ends. It's like math homework. It never ends. Math notes. Math class for some of you never ends. I know. That's probably why you're here. At any rate, we will be posting together. You'll mostly see my name, my voice, but it's mostly our work and her work put together. Some quality math stuff for you for all year long. But we will be putting notes for every single solitary lesson online. And you can watch these videos anytime you want. They're free of charge. There'll always be a little donate button up there if you're just feeling so inclined to donate to the cause, but that's okay. We don't care, actually. At any rate, if you have any questions, if you have any suggestions, feel free to contact me. You know, for example, I drink a lot of coffee. If you try to send me some sponsors, that'd be cool. But if you try to send me to like a coffee rehab place, we're going to have issues. We are going to have issues. But you'll see me drinking a lot of coffee, as a matter of fact. Okay, for all intents and purposes for today, I will be called Mr. Key. That's a key, K-E-Y. Because that's what we're doing today. Let's get started. You don't want to hear me rant and rant and roll. Let's get started. Okay, so what do these diagrams mean? Well, this big diagram, since we're talking about relations and functions, relations would make up this circle. Now, why would relations make up this circle? And by then, this would be functions. By the way, I hate writing the word function, so if you're in my class, and I hope your teacher does this too, because you'll find out us math teachers are kind of lazy. We like to abbreviate F and C for function. So a relation is just a set of points. A set or collection of points. Well, I can have all kinds of points. As a matter of fact, I can have an infinite number of points. So that's why that circle is bigger. Now, that circle, in effect, could be as big as you want to make it, but since we only have a limited amount of tree space, we kind of limit it to that much. But we can make it as big as we want. As a matter of fact, functions can be infinite as well. Infinity! Oh, it's such a wonderful number. At any rate, functions are a little bit smaller than relations because they're very specific. A function, and let me put this in a little different color for you, is a relation. I want to make sure I get this right. I hate definitions, so normally I don't see me writing too many definitions because now I have to look down and make sure I don't forget a letter or a word. In which each x, or in other words, input value, that should say value. Problem is I'm getting to the bottom of my board here. Value has one and only one y, or output value. So for you big writers, I didn't make the circle big enough. For me, just a sloppy writer, I didn't make it big enough. So the input and output has special names. They're going to be over here. The domain is the input. It's what you're putting in to the function or relation. What pops out is the range or the output. I'll try to work on my handwriting. Boy, this is really, really sloppy. Gonna have to build something better here. At any rate, What was I doing? Oh, so normally I lost my pen point. Normally what we're going to do is call the input values the x values and the output values the y values. Now my big fat head was right there. I totally forgot to move over. See, new video, there it is. Hopefully you saw what I did. All right, new video, new year. Got to get used to my big old bald head getting in the way. So there's lots of different ways we can represent it. By the way, if this is not reviewed to you, go back to your 9th grade math teacher and say, what did you teach me? You were supposed to have taught me all this stuff. Most of this stuff should have been learned in 9th grade. There's multiple ways to represent relations and functions. There certainly are. Well, one way to represent a relation or a function is using, I thought I had ordered pairs. Now what an ordered pair is simply a set, and we represent sets in these nice little curly brackets. Please get somehow this year, get used to writing those. They look so professional when you can write some neat ones, and they look all kind, you know, and then you get the kid who goes, like that. You're like, oh yeah, that's me. Somebody like, yeah, that's me. I know, but try. That one wasn't even that good. Actually, I'm pretty good on paper when I got a pencil in my hand. Look at this big fat pen and this crazy thing I got to write on here. But anyway, they have an input value or the input value. And then we have the output value. Or in other words, the x values and the y values. And you notice here on our table, when we deal our table, we actually represent them by x and y. So these are our input values again. Input. Another way to say input is these are our domain values. And we'll talk about that in a second. And these are our y values or our output values or our range values. Another way to represent it is graphically. We could do it graphically. And you're used to graphing. Basically, I've just taken these 3 points right here and tossed them onto a graph. So another way you can look at it is graphically. And we're going to talk about graphically stuff in a few minutes. And another really cool way to look at it is using, why do I have another yellow highlighter? Oh, just a smaller yellow highlighter. Is what's called a mapping function, where I specifically give you, and the input will be on the left, and the output I'll be on the right. Now, they always call them input and output. They might call them X and Y, or height and weight. They might be calling whatever, I don't know. And then we just map them. We arrow over, and we say -1 goes, -1 goes with 1. And yeah, -1 went with 1. And 1 goes with -3. Notice how these are in order, and these are in order. That kind of more professional looking stuff. So then let's go down here, and it says, okay, what I want you to identify is the domain and range. And every year we'll get a kid that does this. Oh, okay, so the domain is -1, 1, and 4. And the range is 1, -3, and 2, and they're done. But are you really? Because, like, if I look at that and I go, oh, good, you listed 2 sets of numbers. What are they? You have to, and that's why we put this little note here for you, label them. You can't just write or create a list and not tell us what they represent. You have to say, oh, yeah, this is the domain, ding, ding, and this is the range. My next question says, if you're looking at your note sheets, and it's down here at the bottom, it says, which of these allow you to easily see the domain and range? So if I get rid of all my... Why is that not erasing? That should be erasing. It's not. Oh, there it is. Just didn't like me for a second. So if I get rid of all this extra stuff, all my extra stuff, and I say, which one allows you to look at the domain and range the easiest? Arguably, I would say that the table, because there's the domain and there's the range, and the mapping function really, they're just sitting there. Here, domain, here, range. This one is probably the worst, you know, because you got to go, okay, the domain here is -1, 1, and 4, and if it's any bigger than that or small, you know. And then this one, you got to remember, oh yeah, this one's the domain, this was the input value, and this is the output. I think if you're looking at the table or the mapping function, so I would write down table and mapping function probably right here. They're just the easiest ones to look at. Any other questions on this page? No, Dave, page 1 done. Let's keep going. Okay, somehow I got that on the wrong page. I don't know how I did it. So given the relations below, represent specified diagram, identify the domain and range. So we need to first we're going to do is graph. So you've done this a million times. We're going to graph this -3, -2, that's down here. -2, 2, that's up here. 1, -1, and 3, 1, 3, 1. So I've already said domain, so you can just put a list of numbers here. The domain here is -3, -2, 1, and 3. Domain, first value, input value, -3, -2, 1, and 3. The range are the y values, the output values, the second in these coordinates. So -2, -1, 1 and 2. Notice I put them in order. It makes it look a little bit more professional. I put them in numeric order. All right. So here's my x and y in a table. I want to do it as a mapping function. So, well, these are going to kind of look very similar because the only difference between a table and a mapping function is, well, table's a lot easier, but 30, 40, 50, and 60 is I just have to draw arrows. Well, that goes with that, that goes with that, that goes with that, that goes with that. And the domain and range should be pretty obvious here, right? This is the input values. Those are the domain, 3.4. By the way, every time I draw 4, it looks like that. So get used to it. It's going to be a long year with my 4s, and you're going to hear me yell about them all year long. 5.0. By the way, it's not good enough just to write 5. It's 5.0. You'll notice that in chemistry, those are called significant digits. It's important to put both. And then 30, 40, 50, and 60. Ding, 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 ding. Oh my gosh. So now I got to take these 3, actually 4 points and graph them. So let's see. 0 goes with 75. So 0, 75 would be somewhere around there. 24 now. 24 goes with 2 different numbers. It goes with 40 and it goes with 50. '24 goes with 40 and it goes with 50. I just noticed on my answer key I have a mistake on my answer key, so I have to fix that. And then let's go to 36. 36 goes to 38. 38, what, I got to guess? All right, it's a little less than 40. It's right here. So domain 0, 24, and 36. The range is going to be 38, 40, 50, and 75. So if you look at the next things, let's say it says determine if the relation is represented is for questions 1 through 3 are functions. Explain why or why not. So let's just go up and look at them and talk about them. Is this a function? Now remember, a function states it is a relation where every x value has only one y value. So -3 only has -2. Is there another -3 here? What you're looking for is repeating x values. If we have a repeating x value, then we do not have a function. So let's see, -2 only goes with 2. -2 doesn't go with anything else. 1 only goes with -1, and 3 only goes with 1. So when I come down here, I'd say yes, because, again, we're lazy. Each x has only one y value. Let's look at 2. 3.4 only goes to 30. 5 only goes to 40. 7 only goes to 50. And 9.2 only goes to 60. So yes, Again, same reason, because each x, I should write x value, has only, and it's important that it's only one y value. And finally, this last one, and here is the problem, and I think you probably already recognize it. Here's the problem right here. Notice that 24 has two y values associated with it. And so this answer is no, because number 24 has two different y values. Wow, did I just forget? First of all, I made a U. So V-A-L-U-E-S values. All right, moving on. Should have read the directions on the other page. Sorry about that. On yours, it should be nice, I hope. All right, determine if the relation... By the way, you could always get to us through Algebra 2 Common Core as well. What it'll do is it'll direct you to our NK Infinity site, and all our stuff's there. Determine if the relations represented are functions. Explain why or why not. So we should be able to go through this pretty quickly. Let's look. What we're looking for, and the simple way to look for it is repeating x values, because that will let us know that one x value goes with more than one y value. Sorry about that. Had to take a little break. Get some more coffee. Don't judge. It's Dunkin' Donuts coffee. Delicious. Anyway, let's see. 1.1 only goes with 2. No other 1.1s. 3. I only see 1 3, and it only goes with 2.5. I only see 1 5. It only goes with 7. And I only see 1 10.65. So this is yes. It's a function. All x values, for every x value, there's only one y value. I'm not going to write that down, mostly because my penmanship's horrible. Let's go over here. All right, I see a 120 here. It goes 991. Ah, look at this. Another 120. So 120 goes with 988 and 991. Any others that have a problem? Nope. So no, and then this one's because since 120 has two y values. Pretty simple stuff, right? Let's see. Now, we're looking for repeating x values. So this one, number 5, nope. Number 6 goes with this. Number 7 goes with this. Number 8 goes with this. Number 9. If you were to find one here that when it was a graph and it wasn't function, you'd be looking for like another point like right here. You'd say, oh, look, 8 goes with this one and with this one. But since you don't see 2 points on top of each other, then that is not, this is definitely going to be a function. So the answer here is yes, and then there's no repeating x values, or each x value has one and only one y value. Let me move this over so my big head gets out of the way. When you're looking for if a function is going to, or if a relation is not going to be a function, you're looking for something like this, where you have the x value going to two separate locations. And so the answer here is no, because 26.2 has two y values. So you're looking for that double arrow. When you're looking for the mapping function, you're looking for the double arrow going to two different places. All right, here we go. Graphs of relations and function. Determine which of the relationship is a function or a graph. And again, notice, no dots on top of each other. So this is a function. But a few minutes ago, I just talked to you about this, and I was getting ahead of this. What I want you to notice that 2 goes here and 2 goes here, or 4 goes here and 4 goes here. So if I had to list these out, I'd have to list out 2, 2 and 2, 3. or in this case 4 comma 4 and 4 comma 5. So since both 2 and 4 map or have two different y values, this is not a function. So not a function. Okay, you notice that I have a red shirt on now. I even have a fresh cup of Dunkin' Donuts coffee. That's because I'm updating this video. Oh my god, I don't even have my new glasses on. And these are so dirty. Anyway, I'm updating these videos for 2017/18 so that we're going to add some of the things that should have been there last year or maybe should have been said differently. But anyway, who cares? Let's talk about the vertical line test. You also notice it looks a little neater than it did 2 minutes ago. And we're adding 2 new boxes this year. So we're going to talk about this thing called even functions, and we're going to talk about odd functions. But first, let's talk about this thing called the vertical line test. Now, most of the time, your teacher will probably just abbreviate the vertical line test, not to be confused with the horizontal line test, which we will get to later. Now, if you don't know what a vertical line is, it is a line that goes up and down. Those are vertical lines. Horizontal lines are like the horizon. Like the horizon. Like if you look out at the horizon, think, oh, that's a beautiful horizon. That's for later. Vertical line test goes straight up and down. So the vertical line test is very simple. Hold on just a second. What's going on? Oh, get off. So the way the vertical line test works is quite simple. Let's give you kind of a definition of it. If you can draw a vertical line that intersects the graph more than one time, then the relation is not a function. And I'm not sure if I've yet talked about the fact I'm going to abbreviate function FNC. I'll do that all year long. In other words, in order to pass the vertical line test, it can only hit the graph once. So when we bet back up here, oh, I don't have it up here. Let me go back to day 1. If I went back up to day 1 notes, these are the old notes we used to do. But if I went back up to day 1 notes, notice these were not functions, correct? Well, if I take a vertical line and try to draw that through here, notice it hits more than once. Failed. Not a function. Not a function. If I come over here, can't hit this more than once. One vertical line hit it more than once, not multiple lines. So what we're going to do is, as we go through these functions, we're going to look at them, or as we go through these relations, we're going to see if they in fact pass the vertical line test. But let's talk about this thing called even and odd functions. An even function, first and foremost, is a function. So first of all, I forgot the word a, is a function that is symmetric with the y-axis. So in order for a function to be an even function, it has to be symmetric with respect to the y-axis. We're going to address some other things. Now, this is just a simple introduction to this. This is a simple intro to the idea of a even function. At some point, we're going to get to a point where we start talking about the fact that f of x is equal to f of negative x for all values defined in the domain. We'll get there later. We're going to talk about this. This is just an easy introduction. This is just a graphical representation of how to determine whether or not something is an even function. So let's take a look over here at the parent functions. If I graph a line, is that an even function? No. So this would be y equals x, the parent function of y equals x. What about the parent function of y equals x squared? That, although I'm a little bit off of my drawing, y equals x squared is an even function. Then let's take a look at x cubed, and we'll talk about these functions later on and what they look like, but this is what x cubed looks like, y equals x cubed. That doesn't have symmetry with respect to the y-axis. Let's talk about y equals x to the fourth. Y equals x to the fourth generally will look something like this, where it should actually come down, hit that axis, and go back up. Y equals x to the fourth. Actually, the y equals x to the fourth looks a lot like y equals x squared, but generally when it's got an x to the fourth term, you see a few more bumps and humps and maxes and mins and relative max and relative mins. But yeah, this is symmetric with respect to the y-axis. So what kids oftentimes get confused about is they start looking at, well, this is x to the 1, that's odd, so it's got to be an odd function. This is x cubed, that's got to be a cube, so that's an odd function. And this is x squared and x to the fourth, so those are even. That's a nice start. That is a nice start. But a function is not going to be, sure, the only way it can be an even function is if it has an even degree leading, if the leading coefficient, or the first term is an even. The highest degree term is an even. And it's only going to be an odd function when the highest degree term is an odd. But it also has to pass these ideas, and that is that it is symmetric with respect to the y-axis. We'll talk about that definition of an even function later. An odd function is a function that is symmetric with respect to the origin. To the origin. In other words, it has, it's also known as, if you want to say that, it has 180 degrees rotational symmetry. This is something I think you talked about in geometry last year. You could take the thing, rotate it 180 degrees, and it maps back onto itself. If it has 180 degrees rotational symmetry, it is an odd function. So if we take this line here, and, one thing, you can reflect it into the origin. If I use this as my mirror point right here, its reflection point would be right here, and yeah, it's got symmetry with respect to the origin. Now, I can also do 180 degrees rotation, and that point would go there, and that point would map over to here. The same thing would be true here. This point maps to this point. Or if you took that cubic function and rotated it, it would have 180 degrees rotational symmetry. All right, let me pause this for a second, and then what we're going to do is going to come back and start talking about these. All right, so let's take a look at these functions. First, we're going to ask, is it a function? Once I determined it's a function or not a function, then I'm going to determine whether or not it is an even or odd function. So first and foremost, does it pass the vertical line test? The easiest way to determine whether or not a function is a function, if you're looking at it graphically, is does it pass the vertical line test? And yes, this passes the vertical line test. So it is a function. Yes. Is it an even or odd function? Does it have symmetry with respect to the y-axis? In other words, where's my eraser? Oh. In other words, if I draw this mirror in right here, does this reflect over to here? No, it's not an even function. So it's clearly not an even function. Is it an odd function? Does it have symmetry with respect to the origin? If I plug this point in 1, 1, and I go to the origin, it would come out here. Nope, doesn't have that. So it has neither. It's neither odd nor even. Neither odd nor even. Now, that's hard to say. Say that 10 times quick. All right. Is the next function a function? Does it pass the vertical line test? Absolutely it passes the vertical line test. So yes, it is a function. Is it a even or odd? Well, this would have to be even because both are going up. And again, if I draw in my if I draw in a mirror or a reflection, line of reflection here at the y-axis, are these reflections over this line? You know what? It's really close. It's really close. If this whole thing shifted over just a little bit, it would be an even function, but this is not. So this is neither. Is this a function? This is not even a function because notice, yeah, I could draw a vertical line here, I could draw a vertical line here, only hit it once, 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 only hit it once. But if I draw in this crazy line right here, I'm going to hit this point and I'm going to hit this point. So if it fails at once, it is not a function. There's no reason to talk about even or odd because it is not a function. Not a function. And if you want to say it, that's an FNC. It fails the VLT, the vertical line test. A circle, man, that looks so sweet. It looks so pretty. What's going on down here? Oh my God, but fails the vertical line test over and over again. It is a relation, but it is not a function. Function passes the vertical line test. Yes, it is a function. Is it a even? Well, you should ask yourself, okay, if that's going to be an even or odd, it's got to be an even. Both arrows are pointing the same direction, okay? And that's the end behavior of an even function. But is it an even function? No, it's not, because remember, it has to have symmetry it's got to be symmetry with respect to this y-axis. All right, so yes, it is a function. It is neither. Let's take a look at this one. Going off in either direction, that's an odd function, or thinks it could be an odd function, but it definitely is a function. Now, here's a thing right here where our kids look at this right here and they say, oh, look, if I draw this vertical line in, I hit this more than one time. So here's what I want to do. I want to pretend like this is a microscope. And I want to take this piece, and you do this in science. You go, okay, let's go take a look at what that thing looks like. So I come over to here, I draw my line, and here's 1, and then here's 0, and here is 2. So what this thing really looks like is this. Now if you take this and blow that up to this, that's what it's going to look like. Well, it actually goes to the point 1, 0, but it only hits that point once. Now it's only going to go through this point right here. But, right after that, it might go through the point 1.1 comma 0.2 or something. It looks like it hits it more than once, but it doesn't. It doesn't. So yes, this is a function, but no, it is not even or odd. Neither. All right. And unfortunately, I don't have a lot of good graphs. So is this one a function? For even or odd on this one, we should probably update the graphs on this one as well. Only hits it once. Only hits it once. Only hits it once. Now here, it hits here because this is solid, but it does not hit here. An open circle is like a big, huge basketball hoop. It goes through it, but it doesn't touch it. Can't touch this. Can't touch this. So that open circle right there is doesn't hit. So that's a function. This is definitely going to be a function because these open circle holes. Now, whether or not this is an even or odd one is going to be a weird one. So yes, this is a function. Whether or not it's even or odd is kind of weird. Let's see, does this point have symmetry with respect? It doesn't come out here. And this point, albeit comes here, man, that's a tricky question. I would have to say no, it's neither. And because this point does not map to that point. Well, that's not even a point. But that point doesn't map to that point. So I would say it's neither. But boy, is it close. It is definitely close. I think we might be updating this next year to add some more examples of even and odd functions. But I think you kind of get the idea. Yes, this is a function. This is a difficult one for kids to understand again. So what happens here is, if you take this and graph this gets closer and closer and closer and closer and closer to the y-axis, but never, ever hits it. And that's called an asymptote. Asymptote. I hope I spelled that right. I know it's close. Sorry. It's one of those words that for some reason my brain function just doesn't know if it's ever spelled correctly or not. It's kind of embarrassing for a math teacher. So anyway, what an asymptote is a vertical line. It could be a horizontal line, but in this case it's a vertical line that you get really, 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 really close to, but you never ever can touch it because it is undefined at, in this case, 0. So yes, this is a function, but no, it's neither even nor odd. Neither. Hey, we're finally going to get to one. The cosine curve is, in fact, a function. This is the cosine curve. It is also an even function. Because if I draw this vertical line in here, does it have symmetry with respect to the y-axis? Absolutely. So the cosine curve is an even function. By the way, this is f of x equals cosine x. And just for fun, while I'm here, let me draw in the sine curve. You'll see this later on during the year. Let me draw in the sine curve. Sine curve looks like this. Now, sorry, I'm not doing a great job with sine curve. Doing a decent job. So if you looked at that, if you looked at just this curve right here, what would you notice about that? Does that have symmetry with respect to the origin? In other words, if I took that sine curve and rotated it 180 degrees, would it land back on the oldest sine curve? Absolutely. So the sine curve is an odd function. So this is the cosine curve. That's an even function. Why? That's an even function. But f of x equals sine x, which is the green / yellow there, that is an odd function. And that came up on an old Regents exam. That's when we realized, oh my God, we didn't teach that. We need to fix it. So we fixed it. There it is. Go back to old me. 1 year ago, old me. That was 48-year-old me. This is almost 49-year-old me. So see ya. Catch you all on the flip side. Bye. Oh, I'm really upset with the way this went from Microsoft Word to, I'm going to try something different next time. See if I can get this to get on one page. This is kind of silly. Writing a function should be easy. It's easy. Okay, so normally we write y equals. We're going to write now y is the same as f of x. Again, this is review. What this says is y is a function of x. Y is a function of x. So we're going to write it in f of x notation. This is read f of x. That's how it's read. The functional value at x, f of x. So write a linear function. It didn't say write a linear equation. It said write a linear function. So you know those are all normally in the form of y equals mx plus b, where m is the slope and b is the y-intercept. But we're going to write this in function notation. So we're going to write f of x equals. Now our slope's -3, so that's -3x and a y-intercept of 4 plus 4. All right, I need to take a quick break. I'll be right back. So, just real quick. I mean, this is just basic stuff. I don't know what happened to my screen. Here we go. All right, there we go. Oh, it's not working. There we go. So, if I need to write each of these a function, what I'm going to do is I'm going to write it without y. I'm not going to write it as y. I'm going to write it in function notation. F of x is equal to the absolute value of x plus 8 minus 2. F of x is equal to x squared minus 4. F of x. Oh, wait a second. Ha ha. This is not a function written in x, it's written in t, so I have to be careful here. F of t is equal to 10 to the t. So you got to be very careful on that one. In this case, the independent variable was not x, it was t, so I had to be careful. All right. Evaluating functions. Oh, all right, so I want to evaluate f of 5. So I'm going to write f of 5. Now, notice what was here. It was an x. So everywhere I see an x, notice I said I want to use parentheses with angry eye emoji. I want to use parentheses, so I'm going to put parentheses with a 5 plus 7, or plus 17, because what's going in for x is 5. So notice x is here, and it goes in for this. X is here, it goes in for this. Again, this should be review from 9th grade Algebra 1, but that was like 2 years ago, so we'll take it as if you've forgotten. 5 plus 17 is 22. We'll get past that one. Now, I always sub in. By the way, it doesn't matter what letter you use. Normal mathematicians, because we're really cool, we like to use F, G, and H. But because my name's K, Krause, sometimes I like to use K because that's cool. What? Oh, it's cool. So here we're going to do G of 0. And so everywhere I see an X, I put equal sign twice just for fun, like double equals. All right, I'm going to put a parentheses 0, parentheses minus 1, parentheses plus 2. Well, 0 minus 1 is really negative 1, and the absolute value of negative 1 is positive 1. So this becomes 1 plus 2, or 3. So G of 0 is equal to 3. Now here's where it becomes really important. H of negative 1. And I should probably get my calculator up. And so what I'll use is negative 1 squared plus 7. Hold on. I don't know. Whatever. So come back over here. Negative 1 squared. Negative 1 times negative 1 is positive 1 plus 7. So that equals 8. So H of negative 1 is equal to 8. By the way, the calculator we're going to be using is this TI Inspire. And if you go to my website, well, when you go to my website and you go to underneath calculator resources, or going to New York State Teachers and Calculator Resources, I teach you how to get this calculator. Now, I would suggest you buy it for class. You can use it in class every single day. If your school doesn't provide that for you, just grab one. Otherwise, you can get it. It's kind of expensive. It's $120. But if you cost analyze that over all of your rest of your career in high school and all of college, it's like $20 a year. It's not a big deal. But if you wanted to, you could just rent it, but it would only be on your computer. You can rent it from them for, I think it's $27 for a year. And so you can get this on your computer at home and have it there for $27. But anyway, here's what I want to show you. And all calculators kind of work this way. If you were to just type in negative 1 squared plus 7, you're going to get a strange result. It's going to tell you this is 6. And the reason it's going to tell you this 6 is because this calculator and almost all the TI calculators, whether or not you're using the 84 or 82 or whatever, will do the squared first and then tag in the negative. Okay? So anytime you substitute in, I can't stress this, and Miss Newman and I stress this over and over and over again with our kids. You have to use parentheses plus 7, and you'll get the right answer of 8 this time. So anytime you're going to substitute in, please use parentheses. So T of W here, so we're going to do T of negative 2. So everywhere we see a W, we're going to put parentheses. Oh man, how about a minus here? Now I'm not going to be like you kids and just make things. So minus 2 times negative 2 squared. Oh, this should be negative 2 in here. And then plus 5 times negative 2 minus 8. All right, let's see what we got here. Negative 2 cubed. Negative 2 times negative 2 times negative 2 is actually negative 8. Don't write negative 6. It's negative 8. Minus negative 2 squared is 4 times 2 is 8, so minus 8. 5 times negative 2 is negative 10. And then minus 8 again. So negative 8, negative 8, negative 10, negative 8, that's negative 34. Now I could check it using my calculator. I could do negative 2. Now this button right here, over here, off to the left, that one right there is for 3. But notice I'm still in exponent mode. The only time you're not going to be in exponent mode is if you use the squared button. Like if I just start typing now, notice I'm still in as an exponent. So you have to hit that right arrow to get out of exponents. Notice how the line got longer. See, shorter, longer. Forgot what else was got. Minus 2 parentheses. So minus 2 parentheses, negative 2 parentheses, squared automatically. I'm okay, I'm back in not exponent mode. Plus 5 parentheses negative 2 minus 8. Negative 34. Another way to do this is to use this stow feature right here. See this feature right here? It's called stow. We're going to use that feature. So I could say negative 2. And notice stow's in blue, so I'll do control bar, and what was the variable we used? W. So we'll call it W. So what we're doing is saying take negative 2 and store it into W. So now anytime I type W, I get negative 2. 3W. I get negative 6 because that means 3 times W. So now I could type it in as just as it appeared. W cubed, get out of cube mode, minus 2W squared plus 5W minus 8. Negative 34. It looks, and you can look at it, it looks exactly like the problem originally, but we stored in negative 2 in for W. Another way to do it. All right. So let's evaluate each of the functions from above. So f function says we're going to add 17. So f of 3 is equal to 3 plus 17. Oh, that's easy. That's just 20. The g function, I'm going to look down at my notes. The g function was g of 3 is equal to the absolute value of 3 minus 1 plus 2. Well, 3 minus 1 is 2, and the absolute value of that is 2, so this would be 4. H of 3, now that was when we did, let's see, what is the h function? T squared plus 7. So 3 squared plus 7, that would be 9 plus 7, which is equal to 16. And t of 3, oh man, so we got to do, so t of 3, I'm going to run, oh, my big head's in the way here. All right, so I'm going to do it up here. T of 3 is equal to, let's see, I got to look down at my notes now because I can't see it. 3 cubed minus 3 squared plus 5 times 3 minus 8. Let's see. This 3 cubed, 3 times 3 times 3, that's 27. Again, I might just use my calculator on this. Minus 3 squared is 9. 9 times 2 is 18. 5 times 3 is 15 minus 8. Let's see. 27 minus 18 is 9. 9 plus 15 is 24. 24 minus 8 is 16. Let me just check. Ooh, I got it. This should be on the other page, but okay. So here's my function k. Oh, notice it's k. K is wonderful. Okay, let me take a quick break. I'll be right back. Took a little break of coffee. Anyway, I have to take those breaks. If I go too long, sometimes the audio gets out of sync with the video, and that looks kind of funny. So here's my k function, all defined out for me. Let me highlight it in blue like this. Here's my k function. Now remember, this is my input value. This is the input value. And these are all of the input values. K of -2, this whole thing is saying, what is my output value or my y value? What is my output value? So if I put in -2, what do I get out? And that's this one right here. This one right here. If I put in a -2, what do I get out? I get out 2. So I apologize for having to do this here, but K of -2 is equal to 2. What is M of 7? So remember, this is my input value or my X value. So I'm going to put in a 7 and I get 50. So M of 7 is equal to 50. N of 0, remember, 0 is my X value. If I plug in a 0, I get 75 out. So N of 0 is equal to 75. P of 1, again, remember, this is my X value. So I got to go, X is 1. I want to find out my functional value. So P of 1 is equal to 3. So now I just want to do these last couple, and I think we're done for the day. Oh my gosh, I'm so excited. By the way, if you haven't subscribed to my YouTube channel, please subscribe. Hit the subscribe button on the bottom. It allows us to do extra things, and it'll grow our channel, and it'll help your friends find a cool channel that they can get help with Algebra 2 math. So K of 1, we got to go up to the K function, which is on the other page, unfortunately. So K of 1 is right here. So K of 1, this is our X value, and we're looking for the output value, -1. So K of 1 is equal to -1. M of 9.2, right here, 60. This shouldn't have been too much of a challenge for, I hope, most of you. 60, 24. 24 maps to 40, so N of 24 is 40. And finally, P of -1. So I got to come down here, -1, and the Y value is 1. That's it, kids. Oh my gosh, day 1 is over. That seemed to take forever. It kind of did. Anyway, hit the like button, hit the subscribe button, and send me an email if you want. It'll be in the show notes. You can let us know what you like, what you don't like, what you'd like to see. And don't tell me more hair, because it ain't going to happen. Well, okay, it might happen, but this is as long as it gets. You gotta get rid of it. All right, bye, kids. Hope you had fun on day 1. Goodbye. Have a good day. Bye. No, really, go. Really. All right, are they gone? I can drink coffee now. You're still here. Go. Go. The video's over. I know I could press stop, but you keep watching, and I keep having to talk to you. Why do you keep watching? Oh, good, they're gone. No, you're still there. I see you're still there. All right, I'm cutting you off.